Hey everybody, Mark McComb here, taking a closer look at the new Curiosity High Pin Count development board. This is a recent addition to the Curiosity family, and like all Curiosity boards, the goal here is to provide a flexible development platform at a cost-effective price point. Curiosity High Pin Count has 2 sockets and is configured to support 28 or 40-pin 8-bit PIC microcontrollers and PDIP package. There are dual-row expansion headers on either side of the MCU sockets so that the user has complete access to all the pins on the target device. 2 microbus headers are connected to the MCU sockets to enable the use of microelectronica clickboards. This vast selection of expansion boards allows connection to a variety of sensors, wireless modules, and other technologies that you may wish to implement in your application. Curiosity High Pin Count comes with standard interface components including a potentiometer, 4 LEDs, and 2 push buttons. These interface components, along with the microbus headers, are all connected to the MCU sockets through these solder blob jumpers. The reason for this is that should you wish to disconnect these components from the associated MCU pins, all you need to do is remove the solder blobs with a standard soldering iron, and that will break the connection. A jumper on the board can be used to select power to the target microcontroller directly from the USB 5 volts or from a regulated 3.3 volts. This board actually integrates a programmer debugger, so there is no need for any additional hardware to get started developing applications. I've got the Curiosity board connected using just a USB cable to an available USB port on my Windows machine. I've created a project in Microchip Technology's MPLAB X integrated development environment called Blink for the PIC16F18875, which is the microcontroller that comes with the Curiosity board. This 40-pin microcontroller is a great general-purpose device that features integrated analog, core-independent peripherals, and some really nice low-power features. Let me open Project Properties where you can see that MPLAB X recognizes the Curiosity board, which I've selected as my hardware tool. This project is pretty straightforward. All I'm doing is toggling the RA7 pin high and low to blink the LED connected to that pin in 500 millisecond intervals using the delay milliseconds library function that comes with the MPLAB X C8 compiler. To program the Curiosity board, all I need to do is click on the Make and Program Device button here at the top of the IDE. Once programmed, you can see that the LED connected to RA7 is blinking as promised. Now, remember, I said that this board integrates a programmer and a debugger. So let's go ahead and set a breakpoint here at the line of code that toggles the RA7 pin by clicking next to it, and then hit the Debug Main Project button at the top of the IDE. Once the device has been programmed, the debugger should stop at our breakpoint we set. If I click the Step Into button, the toggle line will now execute on the microcontroller and our LED will toggle. Curiosity Programmer Debugger is actually compatible with many of the common debug features like Step Into or Reset, or if you want to open watch windows to look at register value changes and so on. For more information on the Curiosity High Pin Count development board, including user's guide, schematics, code examples, and more, please visit www.microchip.com/curiosityhpc. My name is Mark McComb. Thanks for watching.